Hey guys, welcome back. So today we're working on this 5,000 watt Homelite generator. It is powered by a 9-horse Subaru engine, and although a bit dirty, I think this machine's going to clean up pretty well. And I found it on Facebook Marketplace. The seller was only asking $100, and once you factor in that it comes with $100 in cords, the machine is basically free. That said, though, I did pass on it for about a month. I have a lot of machines that need to be repaired, and the last thing I needed was another. But then he dropped the price to $50, and I couldn't pass up the deal anymore. So, according to the listing, the engine runs well, but it is leaking fuel. So, likely that is a carb issue, and hopefully an easy fix. So, let me get you set up a little bit better and get going on this. Although the price was right, there's two things that make me nervous on this machine. First one is the tank. It is a metal tank and it's proprietary, so you can't replace it. And although the fuel looks old, I don't see any rust in the tank, so that is a good thing. And the other thing is the carb. The OEM one, it is still available. I haven't looked at the price recently, but last time I thought it was up around $200 or $300. So hopefully the carb isn't in too bad a shape. All right, so let's get the fuel drained out. We'll leave the valve in place. Right now it's in the off position. Well, the fuel that came out definitely doesn't look good. Thankfully, there wasn't a lot in there. And surprisingly, it doesn't smell bad. It actually still smells like fuel. Anyway, let's pull the drain bolt on the carburetor and see what comes out of there. All right, let's see if this is going to come off. It's a pretty thin diameter bolt, and sometimes they just break off, but this one broke free. And yeah, carb is full of fuel. Looks a lot like the fuel that came out of the tank. So no water, minimal debris, and the bolt doesn't look terrible. There is maybe a little varnish or corrosion, but I've seen quite a bit worse. So there is a chance this carburetor does run the engine. So let's check the oil real quick. We'll check the filter. And if everything looks good, we'll just feed the carb a bit of fuel and see if we can get this engine to start. All right, let's check the oil out. It should be filled up right to the last thread. And yeah, it's pretty much there. We have plenty of oil. The oil smells good, so not contaminated with fuel. It is pretty dark though, so we are going to have to change it. But let's hear it run first. And they do have a foam filter, which at about this age tends to turn to dust if it's the original filter. So the filter looks good. And actually this one, yeah, it's falling apart. So we're going to need a new one of these. Foam filters, you always have to oil up, or else they're not going to catch the fine particles. Subaru actually recommends a mix of oil and diesel, but most call for just oil, and that usually does a good job. So I'm going to soak the element. We'll just use a paper towel to get the excess out, and then the filter should be good. All right, I'm just filling up the carb with fuel. Now, the guy selling this did say it had a fuel leak, so, likely it's coming from the carb. Guess we'll find out in a minute. And I'm also noticing, too, the ignition switch, it's missing. So, I should probably get that fixed before trying to start it. And yeah, we are flooding over. Yeah, it's flooding out pretty bad. So that needle and seat aren't even trying to seal. But at least we know the carb is getting fuel. So I'm going to mop up this mess. We'll fix that switch. And we'll try to run it as is. The carb, assuming the jets aren't clogged, should be able to start the engine. As far as the switch goes, it looks like the knob just broke off. The switch itself likely is still good. But given the little nub that's left, I don't think I'm going to be able to operate it properly, which we might want to do depending upon how things go. Now, the throttle plate, thankfully, is not stuck. So theoretically, this engine shouldn't run away. But if there is a problem, I definitely want a way to shut it down. So let's follow this wire out back. We'll bypass this switch for now and rig up something temporary. Okay, so that wire from the switch comes down right to there. And the way that switch works is that when you click it into the off position, it picks up ground from the blower housing and passes it down here, which leads to the coil. So if we unplug this wire, we can plug a different switch in, one end there, the other end to ground. And at that point, we'll have a switch that works. So for this, we're just going to use a switch from a Briggs storm responder. I seem to have a lot of those for some reason. And they're good switches. So we need to make up 2 wires. Going to strip both ends. One end's going to get a bullet connector. And the other end, a spade. And then on the other wire, we're going to need a spade and a ring terminal. Okay, that one's good. And this is shrink tubing, but it's not worth shrinking. That's only going to be on here for testing. So we got that plugged in. That leads to the ignition coil. So when this is grounded out, that'll shut the engine down. So technically, we don't need a switch. We kind of have what we need already. So if you don't have a switch, you don't really need one. But in this case, I'm going to use a switch. And for that, we need a ground wire as well. So we'll get that secured. And the switch, we'll click it to on. And connect one end to the coil, the kill wire, and the other end to ground. like that. So what do you think? The guy said it did leak and it ran. So he was right about the leaking. Hopefully we can say the same about the running. So I'm actually going to turn the choke off given we are pretty flooded with fuel. The ignition's on, we've got a light plugged in and turned on, and also have the kilowatt. So let's give it a few pulls, see if it shows any signs of life. I am shocked that this thing just ran as well as it did. The carburetor clearly has issues. Also, these Mikunis, even when clean and working perfectly, love to run the engine lean and surge without a load. But this one ran the engine perfect. There was no surging at all. So aside from the needle and seat problem, the carburetor is actually doing pretty well. And the generator is making power. Now, we do need to tweak a few settings. The voltage was kind of on the low side at 115 volts, and the engine speed also on the low side at 58 Hertz. So, those are easy adjustments, but let's get the carb running right first, and then we'll fine tune it. Actually, let's pull the drain bolt before working on that carb. So we'll let that oil drain for a bit. It's pretty dirty. I want to get as much of that out as I can. So we get the carb off, just 2 10mm nuts right there, and one right there. And something you should be aware of too is that the gaskets on these Subaru engines pretty much always tear. So if you're going to take one of these carbs off, most likely you're going to have to replace the gaskets. And hopefully I have some gaskets. I should. I try to stock these because you pretty much always need them. Of course, I say that. And the one on the airbox came off clean. Okay, take that back. It's broken. I might have done that. But I think it was going to happen anyway, because that gasket, the remnants, I think are partially holding this carb in place. Okay, looks like the whole insulator is going to come out here. Huh. And we're too close. We can't actually get it off the studs. Yeah, there's no chance of getting that off. So I guess we have two options. Either we pull some of the engine mount bolts. That should allow us to pivot the engine away from the frame. The alternative would be to get the insulator separated from the carburetor. So I think we'll try that first. Okay, there we go. Seal broke, of course. But now we have our prize. All right, so let's get it drained out again. Hoping this one isn't too bad. You know, based on the evidence so far, I would say this carb should clean up. So we'll start by getting the bowl removed. And that came out pretty easily. Another good sign. Yeah, a little bit of corrosion or varnish. Not a good sign. That bowl does not want to come off. There we go. All right. Not too bad. The bowl looks really good. Just a bit of debris. But that will clean up. Needle is 100% stuck. So let's try to get the main jet out. That has to come out first. Otherwise, the float will not come off. There we go. And the pin's in there pretty good. So let's try the center punch. See if we can get that pin out of there. Okay. So even with the pin out, you know, we're not going to be able to get the float out unless the needle moves. So a little bit of penetrating oil. And actually, if you blow compressed air as well into the fuel inlet, sometimes that'll unseat the needle without causing damage to it. Yeah, it's pretty stuck in there. So actually, I'm going to soak it in the ultrasonic first. A lot of times that'll free it up. So let's also get the pilot jet out. And then we'll give it a pre-soak. And with any luck, that needle should free itself up. And the pilot jet, it is just a press fit. So you should be able to kind of wiggle it and pull it out. Like that. Yeah, and besides the needle, that's pretty much it. The emulsion tube on this one, it is not removable. Let's see how we're doing. It's only been about 3 minutes. Carb is looking pretty good. And the needle is unstuck. So perfect. Give this a few more minutes. But the main issue on this carb was the needle. But we still need to clean the seat. So let's run it a couple more minutes. Well, originally that was going to be a pre-soak, but things cleaned up really well. And given the carb ran the engine well, I don't think we need to clean it anymore. The big issue was the needle being stuck like it was, and it freed up, came out in one piece, and actually looks to be in good shape. So there is a decent chance that it's going to form a seal. So we'll get it reinstalled on the machine, but I think first I'm going to fill this up with some fuel. We'll just bench test it and make sure that the needle is actually working. Okay, that looks good. Get the main jet back in. Okay, that is good. Get the bowl reinstalled. And lastly, the pilot jet. Where is the pilot jet? Aha. I was getting worried. Pilot jet. I thought it was lost. So we'll get that back in. Screwdriver just to push it down and get it fully seated. And then we need the retainer to make sure it stays in place. I guess we'll clean the gasket off first. So this one, well, fell apart, but at least it came off clean, or at least clean enough. This one almost came off, but we're missing a couple chunks. So likely we're going to have to scrape that off carefully with a razor blade. And I think the more challenging one is the gasket left on the engine. Very hard to access, but let's get this cleaned up first. So we've got the carb and the insulator cleaned up, ready to go. But now for the hard part, the insulator right here. We have the ignition wire in the way, so you can't really scrape it unless you move it. And still, the studs are going to prevent getting this spotless. So we might need to pull the studs, but let's try this first. See how far we get. Yeah, not perfect, but I think it'll be good enough. So I'm going to get this cleaned up a bit while we have access to it. And the fuel lines, they actually are fine, but the clamps, they're rusted out. You know, they're getting pretty close to failing, so we'll get some new clamps on there. New fuel filter. And I also want to get the carb not really installed, but just sat on the studs. We'll put some fuel in it, just make sure it's not going to leak. Okay, so now we're nice and level. Add some fuel. And what we want to see is that the needle closes and the fuel stops advancing. Before, it was just stuck wide open. And the flow is slowing. So good. Needle and seat seem to be working. So I'm going to leave it like this for 5 or 10 minutes. And while we're waiting to see how this works out, get some oil back in the engine. Well, the oil that came out actually looks pretty good. Aside from being well used, I don't see any metallic in there, no glitter. So the engine likely is in good health, and the rest of the machine is also cleaning up pretty well. It's not done yet, but it is coming out pretty nice. Not to mention the carb, it's holding steady. So it's been about 10 minutes, and I would say that needle and seat are good to go. So let's get this out of the way for a minute. And we'll get a new gasket on. So this is the one that goes between the engine and the insulator. Like that. And then we'll get the insulator on. And set back in place. And a new gasket for this side as well. Then we can get the carb in place. And the anti-surge spring. And you have to be careful. This kind of gets wrapped around the governor spring. So you want to make sure that the two can move separate. Yep, that is good. And the one gasket I don't have is the one that goes right here. So, we're going to have to make one. This is the least important of the three. Really, anything between the carb and the engine has to make an absolutely perfect seal. This one, technically, we could probably just find the other half and bolt the box on, and it would seal good enough. But yeah, let's try to make one better than that. All right, so let's make up a gasket for the airbox side. So I'm just going to start with a piece of gasket material, and we're going to punch out the center holes. So I'm going to use a a punch for leather. And this piece right here, it's a little bit larger than it needs to be, but it should be good enough. And I think we need to hit that again. And this carb bouncing around, it is a parts carb. It's not the one that's on the machine. And that one has issues, but it's going to serve us well as a good template. And we're still hanging on a little bit. So let's give it one more shot. There we go. So that was the easy part. The harder part is to get the holes for the studs in the right spot. So I'm going to use a punch to locate them. And actually, I'm going to leave this punch in here just to hold it in place, and we'll do the other side with a different punch. Okay, and there should be another hole, I think in this corner for the bowl vent. Nope, not that corner. It's actually up there. Okay, so those are the important holes. I am going to use just like a paper punch to cut them out nice and round. And we do need to nibble a little bit right here where these air jets are. So I'm going to mark those up. Yeah, something like that. Okay, that looks good. And maybe a half circle or less right here. Okay, that looks good. We do need to cut out the outer shape, which doesn't really have to match, the original. It can be square. It doesn't really matter. And I do have half the gasket. The other half, I'm not sure what I did with, but I think I have another gasket. It's kind of worn out, but it should give us the full basic outside shape. And definitely a little distorted and worn out. And you can see it's actually slotted right here. So the airbox, for whatever reason, is slotted, whereas the actual vent on the carburetor is not slotted. But I might elongate that a little bit, although I don't want to breach down there. So we might go up a little. Good enough. Okay, let's try that out. Perfect. So I'm going to crack the lock nut free here on the adjustment for the governor. And of course it's pretty tight in there. So let's see if I can get a socket on there, potentially use the impact to break that free. Yeah, I think the impact actually spun the screw as well. So the engine speed's going to be even slower than it was, which is fine. You know, we'll set it once it's running next. But before I get it started again, I do want to pull the end cover off the generator and make some adjustments there to bring the voltage up. All right, so there is a potentiometer here. Usually one full turn clockwise will get us about 2 volts. Sometimes quite a bit more. So I'm only going to do 1 turn to start with. And we'll see what that gets us. All right, the ignition's on, choke's on. So I'm going to get the engine started. We'll double check the output real quick, make sure the voltage is within range of 120 volts. And assuming all looks good, we'll adjust the engine speed to about 61.5 Hertz and then shut it down. Yeah, voltage came up quite a bit to 140. So sometimes just moving this potentiometer and then setting it right back is all you need to do. You know, the wiper gets a little dirty. So we'll bring this back 3/4 of a turn and see where the voltage is at. All right. Take 2. So that was pretty good. Voltage, maybe a little bit on the high side still. So we'll back that off a bit. That should get us a little closer to 120 volts. So let's double check. Okay, that lock nut is snugged up. Engine's refueled. Ignition's on. And I think that pretty much did it. So now we're at 61.3 Hertz, 122.7 volts. So the engine's running well, the clean carb is working perfect, and the voltage is dialed in. So I'm going to resecure these wires, and we'll get the cover back on. So it's very important you secure this bunch of wires. A lot of times it is bolted right to there. In this case, the manufacturer chose to just kind of scrunch the wires to the connector, which also works fine. Like that. Cut off the excess. And it looks like we also have some pretty long wires here. So they also tried to zip tie it out of the way of the rotor bolt, which they did. So I think that's should be good. And these bolts, don't make them too tight. They strip out of the aluminum very easily. I almost forgot. We need a new one of these. So I just ordered one off of Amazon, $8. It'll be here tomorrow. All right, let's finish this up. We've got the new switch from Amazon and hopefully a direct replacement. Although I can tell already this wire might be a little bit shorter than the OEM. So hopefully that isn't going to be an issue. So yeah, the part seems to be the same, at least as far as the switch goes. It picks up ground from this terminal right here. That's where one of the screws goes into the blower housing. So I don't think we're going to have any issue there. But yeah, the wire, quite a bit shorter on the new switch. And as it is, the old switch, that wire just barely reached. So what we need to do is actually cut this wire off. We'll attach it to the new switch to give it a little bit more length. And quite a bit thinner gauge on the aftermarket switch. So yeah, maybe OEM was the way to go here. I mean, this should be fine, but obviously if you have to modify it to work, then it might just be worth ordering the OEM part. So for this wire, because the gauge is so thin, we're going to have to probably fold it over so that the connector I use is a little bit better matched on both ends. Okay, that's a good connection. So I've got a piece of shrink tubing on here. We'll just shrink it down. Then get this installed. Let's test the switch real quick. Given the fact that it's an aftermarket part, I'm not sure how much I trust it. So right now it's connected to the multimeter, set to test continuity. The switch is in the run position, so there's no connection. Let's flip it to off, on, off. So good. The switch seems to work. And all we need to do is unplug the temporary and get the replacement plugged in. And that is it. So we'll just get the old switch completely off the machine and we should be good to go. All right, let's give this thing a quick try. And I mean real quick, because rain, it is going to start in about 5 or 10 minutes. So let's get the engine started. We'll double check the outputs using the kilowatt to measure the frequency and the voltage. We'll use the amp probe to measure the total harmonic distortion and the oscilloscope to see what the sine wave looks like. We'll then put on a half load of 2,500 watts. We'll give that some time. If everything checks out, we'll go for the max of 5,000 watts. Alright, so no issues getting it started, although it did let out a bit of smoke at startup, which for these Subaru EX30 engines, very common. I think they pretty much all do that. So, you know, without a load, voltage and frequency look good. THD starting fairly low at about 4%, and the sine wave, it is definitely jagged. So I don't think this one's going to be a low THD machine. But let's put on a half load, starting with 2,000 watts. No issues at all. Now we're at 2,500 watts, so it's running fine, although it did get pretty loud. Almost sounds like knocking. 13% THD, and the sine wave not as jagged, but also doesn't look too good. So let's give it a few minutes. If everything checks out, we'll go for the max of 5,000 watts. And no issues at all at 2,500 watts. So yeah, it is pretty loud. I don't think it's knocking. You know, I think something is vibrating on the machine. So let's try to bring the load up some more. Now, this engine, it is only a 9-horse engine, and actually 5,000 watts is very hard for it to do. And when you consider we have a 100-watt light on and 200 watts of cooling fans, you know, when I bring this up to 4,500 watts on the load bank, we're actually going to be close to 4,800. And, you know, likely that's all we're going to get out of it, because if we actually go to 5,000 watts of load, plus those other two loads are going to be at 5,300 watts. And this engine really can't do that. But let's try 3,500 watts, no issues. 4,000 watts, it is quite loud. So let's swap these lighter loads back to 4,000 watts. How about 4,500? 5,000. And yeah, it's out of power. So right here we're at 4,500 watts of load, plus the other loads we're at 4,800 watts. About 15% THD, which actually isn't terrible. And sine wave, fairly typical. So yeah, let's give this a few minutes, make sure everything runs well. All right, no issues at all, pulling close to its rated load. So let's try 5,000 again, see what happens. I mean, technically it's doing it, but the engine speed's too slow. We're at 55 Hertz and dropping, so yeah. Definitely can't do more than its rated load on this machine. You know, the engine just doesn't have enough horsepower. So let's give it a few minutes. We'll let the engine and the load bank cool down, and then we'll shut it down. And that is pretty much it. So this machine actually performed as expected. You know, the engine, it is a small engine. It's 9 horse, and 5,000 is it. It cannot do any more than that, and that's what we saw. Now, as far as the noise goes, you know, the heat shield, it is secured properly. You know, it does not appear to be damaged, but it's just oscillating in such a way that, you know, it makes a terrible noise. And to be honest, this heat shield design isn't the best. It's only secured on the right side and really nothing over here. So that's what is causing the noise that we heard. Anyway, at the end of the day, we've got this machine back up and running and performing like it should. And just in time, because the rain, it has just started. So I hope this video helps someone. Thanks for watching.